Let's talk a little bit about midpoints. So midpoint is a fairly straightforward concept. It's very close related to something already done, which is bisect. That was not supposed to happen, which is bisect right here. And so if you know that bisector means to cut something in half, the midpoint is designed to help you find that exact bisection point. Now, if there's a line that bisects, it's not going to help as much, except it at least gives you one point in that line. But in the end, the midpoint helps you find the point of bisection. That's really all it is. And so to give you like maybe a little visual, if I have this point A, and let's say it connects to B, um, all I'm talking about for the midpoint is the guy that goes directly in the middle. That's the midpoint. Okay? Try to write that a little better. Okay, it's a midpoint, but it's equally called the bisector because that has to be true as well. And so even though we calculate the midpoint because say it's on a grid, we can also call it the bisector because it cuts it into two, that cuts the line segment AB into two congruent halves. And so this is just a formal way to help you find the bisector, other than having to kind of guess at it, I guess, or sketch it. In terms of finding the midpoint, there's a couple of different ways we can do it. The first way is to think about counting. There is a formula which we'll talk about in a second, but in the end, if you want to find the middle of a line segment, you just have to know how to get from one end to the other and then cut that distance in half. It's an indirect thing. I know it sounds kind of nuts, but let's go ahead and get into it because I think you'll find that it's actually a lot easier than it sounds. So let's say I want to find the midpoint of line segment AB. Well, first I have to understand how to get from A to B. Now we're going to talk about an indirect distance, which is very, very similar to looking at how you travel with slope. But what I mean is, if you're starting with A, you can actually just go over a certain amount, and then you can go down a certain amount, and you can end up right at B. Okay. Now, in terms of how you move, well, you can just actually count this distance. So you could say to go from A to B, all you really have to do is go to the right 1, 2, 3, 4, 5. So to the right 5, and then down 1, 2, 3. Okay. Now that tells you a whole indirect distance from A to B, which would be a whole indirect distance. Okay. So the whole indirect distance from A to B is over 1, 2, 3, 4, 5, and then down 3. So if I want to talk about finding the midpoint, that means then half that journey, okay, half that journey is going to be half of 5 and then also half of 3. And so half the journey is going to be, let's see, right 2.5, and then down 1.5, because that's what half of 5 and half of 3 is going to be. Now we can check that here on the grid. Okay? And so instead of going over 5, if we go over 1, 2.5, and then instead of going down 3, we go down 1.5, we should actually land directly at our midpoint. Okay, so that's going to be the midpoint. And if we want coordinates for that, it looks like it's going to be over negative 0.5, and then up 1, 2.5. Okay? And so that's a totally legitimate way to think about midpoint. And so again, without the calculation, you can this is still a possible exercise. We just have to think about like the journey we take from one point to the next, and then having that journey. If this had been like over 20 and then down 10, half that journey would have been over 10 and then down 5. And you see it should land right on the line, and your midpoint should always land right on the line because it has to be the halfway point of that line itself. Now, if you're not fortunate to have a graph, that's okay. You can still actually do this work because we actually do have a midpoint formula, and we see the pieces just like the slope formula are going to be pretty familiar. The x1, y1, x2, y2 just refer to points. So like the x1 is just the first x value of that coordinate. The x2 is the second x coordinate of the x coordinate, excuse me, of the second point. The y1 pairs with the x1, and the y2 pairs with the x2. And so this is, again, it's going to be a formula. We're going to take values, plug it into the formula, and see how it works. And so, for example, if I were asked to find the midpoint of the segment that has endpoints negative 3, 4, and 2, 1, I can first come in here and just make sure I can label everything. x1, y1, this will be my x2, y2. And then I can apply my midpoint formula. So my midpoint formula says the x value of my midpoint, the y value of my midpoint, is the same as taking x1 plus x2 over 2, y1 plus y2 all over 2. Now, this is just finding the average. So in terms of finding the middle, please recall that this is how we average numbers together. We add them together and then divide by how many numbers we have. In this case, we only have 2 numbers, so we're only averaging 2 together. Now, in terms of substitution, this is going to be very straightforward. x1 is going to be negative 3. Okay. My x2 is going to be 2. This will be over 2. My y1 will be 4, plus my second y value, which is 1, again, all over 2, because we're just going to average them together. And so the halfway point, if we go from negative 3 all the way to 2, is going to be negative 1 over 2. If we go from 4 end up at 1, that's going to be 5 over 2. Now, in truth, we can just leave our midpoint just like this. We don't have to take it to decimals, but we can if we want to. But since we just want to find the midpoint and we don't really know the context, I say leave it just as it is. And so that's going to be our midpoint. Okay. So we're going to stop the video there. The next video in the series will cover all the examples in the second part of your notes. But just as a quick reminder, just kind of running down what we talked about, midpoint is just a way to actually calculate where the bisector of a line segment has to be. Please recall that a bisector cuts a segment into 2 congruent parts, so the midpoint has to do the same. It's the exact middle of the line where either side of it will be the same length. You can find it a couple different ways. If you're given a graph, or even if you're given a couple points, you can just think about how far it is in the x direction and the y direction separately to go to A to B, and just cut that distance in half. In this example, going from A to B, you have to go right 5 and then down 3. But if you want to go half that distance to find the midpoint, you just cut the 5 in half, you cut the 3 in half, and get 2 and a half and 1 and a half. Then starting from A, you go half that distance. Instead of going over 5, you go over 2 and a half. Instead of going down 3, you go down 1 and a half, and it should land you directly on that middle point. So even counting halfway in either direction, x and y, should land you in a midpoint. If you're not given a graph, or you prefer to use a formula, you can do that. This is just averaging the x's and y's, which finds the middle x and the middle y, because that's what averages do. So we're going to add our x's together, divide by 2, to get our x coordinate. Add our y's together, divide by 2, to get our y coordinate. And so like in this example, that's all we did. We took our x numbers, we add them together, then divide by 2. And then we took our y numbers, y1 plus y2, added them together, and then divided by 2. And we end up with the point negative 1/2, 5 halves. And that's going to be no different than if we just counted halfway on a graph. That's going to find our midpoint. That's going to find the bisector of our segment. All right, so we're going to stop that there. We're going to look at some examples here in just a second. Thank you.